Right. Okay, welcome back. Let's continue, guys. Can you see this slide? Can you see the slide, guys?
Yes.
All right. So we were talking about this concentration. Why it is like this? Sorry, I have to stop share. It is not shared properly. All right. Okay, it is about the concentration. So if we add the concentration of the product, then it will shift to the left to the reactant in order to make a new equilibrium. And if we add the concentration of reactant, it will shift to the product. And the reverse is for decreasing. If you decrease the product, then it will shift to the product in order to make a new equilibrium. If you decrease the reactant, it will shift to the reactant in order to make a new equilibrium. And the value of K will stay the same. Now here, another things here, we can also add substance which is not the same. For example, in here, if I add NH3, it is the same NH3, yeah? Here, if I had N2, the same N2. If I add H2, the same H2. But here, I can add also different substance. For example, if I have a reaction between A, let's say that A in equilibrium with B, like this, I can add C, for example. And this C, for example, is reacting with A. C and A is reacting. So what will happen? The equilibrium will shift to which part in order to make a new equilibrium? If I add C, which is reacting with A. And the new equilibrium will shift to which part? To the left or to the right?
To the right.
Are you sure? If I add C, which is reacting with A, then the reaction will shift to the logically it's like this. If I reacting C, if I add C to the equilibrium and it's reacting with A, what will happen? The concentration of A will be decreasing because some of them will reacting with C, isn't it? The concentration of A will decrease because some of them will reacting with C. So if concentration of A will be decreased, then the new equilibrium will shift to the left. Very good. If I add C, then it will goes to the left because the A is decreasing. So in order to make a new equilibrium, it must be shift to the left. And the same thing if I have the same reaction A and B, but at this time I add D, which is reacting with B. So what will happen here? The reaction will shift to the
Right.
right. Because B is decreasing, the sum of them is reacting with D, so the reaction will shift to the right. Okay, this is also another thing about the concentration. You can write this one. Do you have any question?
Sir, can I ask?
Yes.
Jadi misalnya yang di kasus yang pertama itu C itu direaksiin sama A. Berarti itu kan nanti reaksinya itu kan B ini sebagai reaktan, C plus A itu sebagai produk yang enggak.
No, C and reacting in A with another reaction. It is not a reaction between A and B. C is as disturbance in here. So if you add C, C will disturb the equilibrium between A and B. How it is disturbed? Because C is reacting with A, then the number of A will be decreasing. If the number of A will be decreasing, then according to Chatelier, it must be form a new equilibrium shifting from B to A. Okay? Any other question? It's clear? All right.
Clear, sir.
Okay, let's move. Now this example here. Okay, let's solve together the example here. The following reaction is at equilibrium. COH2O, CO2H2. Following changes are applied. Try to predict how the reaction respond to this effect. I mean, it's will shift to the left or to the right. Addition of CO. It will shift to the
Right.
Right.
very good. Addition of H2,
Left.
left. Removal of H2O,
Left.
it also left. And removal of CO2,
Right.
right. Is it clear? Any question about this question? Anything which is unclear here? All right, very good. Another question. Now, can you solve this question? All right, I need more space to solve this one. Let me use my, sorry, I'm giving it. I'm waiting for the whiteboard. Okay, now it's coming the whiteboard. Oh my God. All right, I have to clear first this whiteboard and then put it again here. All right. All right. How to solve this question? Consider the reaction. We have the reaction here, and it is an equilibrium mixture was found to contain 2 mole of Hi, 1 mole of H2, and 1 mole of I2 in 2-liter vessel. At the same temperature, 1 mole of Hi is added to the vessel. Calculate the concentration of each substance when new equilibrium is established. Here, which one is the disturbance?
1 HI.
This one, right? When I add 1 mole of Hi is added, this is the disturbance, isn't it? So what we are going to do here, we are going to find out first the Kc for the first for the reaction, and for the first information we can get the Kc because it is already at equilibrium, isn't it? So Kc will be what? Kc will be equal to concentration of I2 times concentration of I2 divided by concentration of Hi square. Is it true? It is equal to what? Concentration of H2 at equilibrium? It is at equilibrium, yeah? H2 1 mole, isn't it? Sorry, yeah, 1 mole also here. H2 is 1 mole because it's concentration, so it must be divided by volume, 2 liter, so it is half here. I2 is also 1 mole here, and we divide by 2 also, it is also half. Divided by Hi. Hi is 2 mole. 2 divided by 2, it is 1 and square. 2 divided by 2 and square, it is become 1, yeah? So it is half times half, it is 1/4. It's 0.25. This is the Kc. Do you agree?
Yes.
Right? So we don't need to use ice to find the Kc because it's already at equilibrium. Now, let's see the disturbance here. We have the disturbance here. Let's see how the reaction shifting. To see the shifting, we are going to write down the reaction here, 2Hi, okay, in equilibrium, H2 plus I2. Okay, in the equilibrium, I got how many mole of Hi in equilibrium? 2 mole, isn't it? 2 mole of Hi, H2, 1 mole, I2 also 1 mole. This is at the equilibrium. What is in disturbance? Let's see, D is a disturbance. What is the disturbance here?
1 mole to the
1 mole,
HI.
Hi is added, right? So it is plus 1 mole of Hi, but there is no addition of H2 and I2, 0. Now, this is the critical part. We are going to find the changing here. How the equilibrium changing when you add this 1 mole of Hi. Now, my question is, when we add 1 mole of Hi, the reaction will shift to which side?
Right.
To the right, right? To the product, isn't it? Is it to the product, right?
Yes.
Because I add the reactant, so it will shift to the product. So what does it mean? If shifting to the product, the reactant will be decreasing minus, and the product will be plus. Because it's shifting to the product. It means that the reactant will be decreasing, the product will be increasing. So the changing is like this. Now, can we make the changing here? Is there any information about the changing?
No.
No. So what we use here? Yes. Let's use it the same with the coefficient here. So let me use 2x here. here also X, and here also X. Remember, if it isn't changing, it must be the same ratio with the coefficient. All right, now, after we know this, we can have a new equilibrium. Let's say the equilibrium 2. Equilibrium 2 is new equilibrium. What we are going to do is just we sum all of them. 2 plus 1 minus 2x. So 3 minus 2x here. Here is plus 1 plus x. Here also 1 plus x. Right. Now, if I know already E2, I can use Kc for the new equilibrium. Kc will be equal to concentration of H2 times concentration of I2 over concentration of Hi square. Okay, now concentration of H2 and I2 the same, right? 1 plus X divided by volume divided by
2.
2, because we have 2 here. They are the same, so I can write it as a square, isn't it? H2 and I2 is the same, like this, the same expression, 1 plus X over 2, so it is, we can use a square. Over, now the concentration of Hi here, concentration of Hi is 3 minus 2x divided by 2, and also we have square here. Because we have square, 2 and 2 can be cancelled. And this one will be equal to what? What is the value of Kc?
1 over 4.
As you can see, Kc is not changing. Don't forget, when we are talking about concentration, Kc is not changing. So now we have a very beautiful calculation here. So it is will be, if I take the square root for both of them, what I'm going to get, it is 1 plus x over 3 minus 2x is equal to half. Okay, so here 1 plus x is equal to 3 over 2 minus x. So from here, mathematically, 1 plus 2x equal to 1.5. So 2x is equal to 0.5. So x is equal to 0.25. Okay, we got the x. The question is, calculate the concentration of each substance when new equilibrium is established. New equilibrium is this one. So the concentration of H2 and it will be equal to the concentration of I2 in the new equilibrium is equal to H2 and I2, this one, yeah, 1 plus x over 2, which is 1 plus 0.25 over 2. It is 1.25 over 2. Berapa ini? Calculate it, please.
0.625. 0.625. 0.5. 625.
6.
625.
All right.
2 and 5.
0 point. This one, right?
Yes.
Yes. Hi, for Hi, it is 3 minus 2x over 2. So it is 3 minus 0.5, isn't it? Divided by 2. So it is equal to 2.5 divided by 2. It is 1.25. All right. So this is the concentration M. Is it clear? How to solve this one? Very good. Do you have any question? Is it okay? All right.
It's okay.
It's okay. Let's continue then. Let's back to our presentation. All right. So this is the answer. And then next one is this. All right. Okay, the next one is this, the effect of pressure. Actually, when we're talking about pressure, pressure and volume is the same. I mean the same, they are have a one package. What I mean one package, if I increase the pressure, automatically the volume will decrease because this is automatic. In a reaction, for example, you have a container of reaction. When you pressure, you press, you increase the pressure, automatically the volume will be decreasing. So pressure and volume is inversely proportional. Pressure and volume is inversely proportional. So they will have the same effect, but they are inversely. If pressure is increased, volume decrease. If pressure decrease, volume will be increasing. Okay, but now what will be the effect? The effect of pressure and volume is depends on the number of moles. The number of moles in the reactant in product. How we can calculate the number of moles of reactant and product is very easy. In the reaction, just you will sum up the coefficient of the reaction and you will get the total mole. For example, in this reaction A plus B, what will be the total mole for the reactant? It is
2.
2. Because it is 1 coefficient A and 1 coefficient B, so it is 2. For C, what is the total mole? It is
1.
1. Okay. Now, if you know already the total mole here, it's very easy. The rule is like this. If I increase the pressure, or it is the same time automatically the volume decrease, then the equilibrium will shift from the high mole to the low mole. Okay, so for this reaction, if I increase the pressure and decrease the volume, increase the pressure at the same time, decrease the volume, the reaction will shift to the left or to the right for this reaction. From high mole to low mole.
Right.
Right.
It's going to the right like this. If it is pressure increase and volume decrease. And if the opposite, pressure decrease, volume increase, then the shifting will be from the low to the high. So in this reaction, if I decrease the pressure and I increase the volume, it will goes to the left. Pressure decrease, volume increase. All right, it is pressure and volume. Do you have any question for this? No? Okay, you can write this one. Don't write the Arabic. It is penampakan aja. Okay, is it clear? All right, let's do example here. For example, we have this reaction. Following changes are applied. Try to predict how the reaction responds to this effect. Increasing volume. Volume increase, pressure decrease, shift to the in this reaction.
The right.
Okay, it must be from low to height, isn't it? Isn't it? It's from low to height, and low is this one, height is this. So to the right. Very good. B, decreasing volume, pressure increasing. So it is the reverse from high to low. So it must be to the left. Okay, increasing pressure, pressure increase, it means volume decrease is also from high to the low. So it will be to the left. Okay, is it clear? Any question? All right, very good. Very simple thing here. Now let's continue. This is the answer. For this, all right, now my question is, what is the total mole for this reactant? What is the total mole for reactant?
1.
I'm sorry, it must be 0.
Yeah, there is solid.
Because this is solid. Solid will not be accounted. Solid and liquid will not be calculated. So in here, in the product, also we have only 1. Okay. Increasing pressure, pressure increase, volume decrease. So to the left, isn't it? From high to low. Decreasing volume, it is also increasing pressure, is also from right to the left. Increasing volume, pressure decrease, so from low to the high, so to the right. Okay, this is very simple thing. Let me pass this one. Okay, guys, the next one is, guys, the next apex is the temperature. Okay, the next apex is temperature. Now, when we are talking about the temperature, the K value is changing. K is changing. Please keep in mind, when we talking about temperature, only temperature that will changing the K, the equilibrium constant. Yeah. If we are talking about the temperature, the K value will be changing. So you will have different K value. And also, when we're talking about temperature, you have to consider the endothermic and exothermic reaction. You have to see whether the reaction is endothermic or exothermic. So it will change also the effect. Okay. What is the matrix here? If I increase the temperature, the endothermic one, the K will be decreasing. What does it mean K decrease? K decrease mean the reaction shift to the left. Okay, here always like that. K decrease means the reaction will shift to the left, to the reactant. K increase is always meaning the reaction will shift to the right or to the product. So if I increase the temperature, exothermic will make the K decrease, but endothermic, the K is increased. It's meant to the right. It is if I increase the temperature. If I decrease the temperature, is the reverse. The exothermic will increase, make K increase, and the endothermic will make K decrease. Okay? Okay, you can write this one also in your notebook. Finish?